Okay, students, fine. Uh, I think all of you know in which subject I am going to take this time. I'm going to take that analysis of structure, okay? Your first subject of 7th semester, BC 701.
Okay, sir.
So for that, I'm going to start the first unit of this subject, that is the unsymmetrical bonding. Okay, class, if you have any doubt, please feel free to ask. Okay, I will try to clear your doubt as much as possible. Okay. Here, let's continue this. So, as I have already said, our first unit is unsymmetrical bending. Okay. So, what is this unsymmetrical bending? We will going step by step. First of all, we will going to the introduction part. Then there are some derivation. After that, we are going to solve some numerical in the coming classes. Okay. So what is this unsymmetrical bending? So there, I think all of you know that there is two types of structure. One is symmetric structure. One is unsymmetric structure. Okay. So please go through the slide. I will explain about this. So for this, what when a section is called unsymmetric. So a section is said to be unsymmetrical if it is cut around in such a way that one section of the one portion of the section is not the exact image of the opposite portion. For example, we consider any section, if we cut it into two parts, if it is not the exact image of each other, then we can say that this section is unsymmetric. Or if we get section, cut it across the middle part of the section, if we get exact image of each other, then we can say that it is a symmetrical section. So for symmetrical section, it is not much difficult to solve any numerical and such things. But for unsymmetrical section, we need to go and we need to follow some other different things. Okay. So we will discuss about that. What is that unsymmetrical? What is that symmetrical section? Okay. So this is all about unsymmetrical bending. So please go through the slide. What it is said that a simple bending theory is applied when bending takes place about an axis which is perpendicular to a plane of symmetry. And if such an axis is drawn through the centroid of a section and another mutually perpendicular to the centroid, then these axes are principal axes. Please remember this term. For every section, for any type of section, we know there is a centroid. Okay? So if we draw two perpendicular axes through that centroid, these axes are known as principal axes. Okay? And this is also the, we can also as plane of symmetry. Okay? So, and one more thing you need to remember, that when we find out the moment of area about any section, okay, of any cross section about the principal axis, then the product of this moment of area, as you can see in the slide, integration xy dA is always 0. Okay, please remember this term. If we find out the product moment of area about any axis, the product moment of area is always 0. Okay. Next, if please see this, all plane section, whether they have an axis of symmetry or not, they always have two perpendicular axes about which we need to find out that product second moment of area, and it always comes out to be 0. Okay. So for understanding these things, what we need to understand what, first of all, what is the principal axis and what is this product of inertia. Okay, so in the later part we will go through that, how we need to find out this product of inertia and what is the principal axis. Okay, so basically what we learn in this chapter, we will learn in this chapter is principal axis and their direction with respect to centroidal axis of the section, moment of inertia of the section about the principal axis, the stress developed at various points of the section due to unsymmetrical bending, product of inertia of section about any coordinate axis, and position of neutral axis with respect to centroidal axis of the unsymmetrical section. So here you see there is some example of some section. Okay, as you can see here, there are some section. For example, like rectangular, I section, channel, and T section. Okay, so you can see that if we cut this section in the middle part of the portion, for some section we will get exactly the same image of each other, means like a mirror image, but for some section we will not get it. If we will get the exact image, then we can say this is a symmetrical section. If we will not get, then we can say it unsymmetrical section. These things you will understand when we solve the numerical and all these things. These are the some formulas we are going to use. These are the formulas we are going to use some while we're solving the numerical. We need to find out this. I will explain it in a later part. Please don't worry about this. So there are some methods for finding out this. There are some basic methods and there are some one method for Mohr circle, length circle to find out the second moment of inertia. So we'll go one by one about these methods. But for going through that, first of all, we need to find out, we need to understand what is the principal and product second moment of inertia. Okay, so for that, first of all, I will go through that. Okay, what is the principal moment of inertia or second moment of area? Okay, please look at this. So what is this product second moment of inertia? Yeah. So for this, we need to consider a area, any particular area. Okay, as you can see in the figure, we are in a random area. We need to consider. So for after that, we need to plot that x and y axis. According to that x and y axis, we need to consider a small area. For that, we need to find out the product second moment of area about the x-axis and y-axis. There is two formula given for about x-axis and y-axis. As you can see in the slide, ixx is equal to integration y squared dA and iyy is integration x squared dA. This is the basic formula. And after finding out both the axes, we can simply multiply that and we can find out the product second moment of area as ixy. This is integration xy dA. Okay. So here you see we are considering a rectangular area in that plot x and y axis, and here also it is explained how the Cartesian coordinates is working. I think all of you know from the school level itself in which axis what is the sign. I think all of you got this. Is it yes or no? Come on, please respond. Okay, here it is explained in terms of h and k. Okay, as you can see in the first coordinate, second coordinate, third coordinate, fourth coordinate, what is the sign is given. How we need to find out the sign convention if a particular area is belongs to in some coordinate. In the first coordinate, what will be the sign? What will be the sign in second? Likewise, third and fourth. Okay, and this is the another method how we need to find out the principal second momentum area. These are the some methods of finding out the second momentum area. In this third, as you can see, again we need to plot two axes, x and y. After that, we need to follow these steps as it is given in the slide. There are two perpendicular, zx and zy. After that, we have drawn two principal axes along the centroid, z, gv and gu. Let us consider a small area A, which coordinates is u and p. For that particular area, what will be the second momentum area about the principal axis? This is nothing but given by uv into dA. So this is the formula how we need to find out IUV. Simply integrate that UV into dA. For that, what we need to find out? We need to find out that NP value. So for this, you need to understand the force resolution. I think all of you got it in the earlier semester how we need to resolve a force in any particular direction. So for that, if you find out U and P, considering this area along the x-axis and y-axis, what will be the U value, what will be the P value. So by force resolution, you can easily find out this U and P value. So I think all of you remember, if we take along the angle, it is always cos theta, and it is against the angle, it will be sin theta. Okay, I will explain this in the later part also while we are solving numerical. For now onwards, you please try to find out U and P and put in this value. Simply calculate. You will easily find out this value. Okay, just simple integration, all these things. So as I have already said, that principal second momentum area any particular axis is always 0. So after finding out this value IUV, we need to put it against 0, and from that we need to find out that twice theta value. Okay, so after that, again we need to find out about one by one, say I u axis and I v axis. For that, I have already given that two formula, Ix equal to integration y square dA. So in this time, we are considering u and v. So Iu is equal to nothing but integration v square dA. Similarly, if we put the v value here, so after that, we need to integrate and we need to find out this Iu value. Just try to solve this, okay? If you, I will give you some extra notes also. From that also, you can easily understand how we need to find out this U and P. Okay. Similarly, by putting these things, simplification, it looks complex, but if you do it by yourself, it's just simple trigonometry, just integration and just convert the terms into theta and all these things. Then you can easily find out this IU and IV. Okay. Remember these two things we need to use while we solve the numerical. This IU and IV is nothing but this can also denote as IXX and IYY. In terms of IXX and IY, if you convert this, like putting the values from the earlier equation, then we can find out this final two terms, IU and IV. So these things we can also do in the Mohr circle also. Okay, when we do the in terms of Mohr circle, there are some another method of Mohr circle and length circle called. So these are all similar things. Just if you learn one, it's enough for you. Let me go through that. Okay, see, I think all of you have this with you. I have already shared in your class group. See this. Please take out your notes also. This is the simplest way how we can find out these equations. Okay, please go through these notes. You will easily understand how we have did this. See here. Here also we are considering a particular area. About that, in that particular area, we draw the axis x and y axis, and the u and v is the principal axis. Please remember that x and y axis is the Cartesian axis, and u and v is the principal axis. So after that, what we need to do, we need to consider any particular point. Here we have considered a point as P. Okay, so for that point P, we are going to find out the moment of inertia, moment of area, and all these things. Okay, all the equations according to that point we need to find out. So all of you please go through this revision and check what it is going through in this step by step. See here we need to consider that point P, which coordinates in x and y axis are x and y, and u and v are u and v as shown in the figure. Okay, so from that point we need to draw a perpendicular PM. See the figure, PM and PN on x and u axis, and there is also a perpendicular MM dash, which we can draw in the u axis, and a parallel line MN dash the UU axis. Okay, first of all we need to draw these four lines. After that, how we need to find out this U? Please check. U is distance, nothing but that GN. Okay, GN, that coordinate distance of that point. Okay, please remember that U is the coordinate, means the coordinate of that P point. If we consider about x and y axis, the coordinate will be x and y. If we consider u and v, that the principal axis u and v, that coordinate will be u and v. Okay, so now we are going to find out about the principal axis. So what is this u? U is nothing but the distance gn, means in the u axis it is the distance u. If we are going through the v axis, that it will be the distance v. So for u, what is the distance? It is gn, and gn is nothing but, if we divide it into two parts, it will be the gm plus m dash n, and m dash n is what? M dash n is the parallel distance of m n dash, so we can replace it as m n dash, and there is also theta angle is given. Let me go to the next. Here you can see how we need to find out g. If we resolve the force along the angle, u is nothing but gm cos theta plus pm sin theta. Okay, please go through this. Gm along the x-axis, if we resolve this, gm cos theta, and along the y-axis it is, remember this, pm sin theta. So this gm is nothing but the distance x, and pm is nothing but the distance y. Just put this x and y, you will get that u value. Similarly, we need to find out that v also. See here, v. What is the v distance? V is nothing but from that u axis, that distance of pn. Okay, pn, and pn is what? Pn dash minus nn dash. See here, pn dash minus nn dash, and nn dash is the that parallel distance of mm dash. So similarly, if we resolve the force along this axis, you can easily find out this u and p. So after that, all the simple calculation, you need to put these values. These are some formulas how we need to find out that moment of inertia about x-axis, y-axis, ixx and iyy. These are the formulas how we need to find out. And about the principal axis, if we need to find out how we can find out, so just putting that value u and v by simply calculating the all the value will finally come out to be the final equation of this tan twice theta. Okay, so all of you please try to solve this. Okay, if you face any problem, please let me know in the next class. Okay, so up to this you try to solve. Okay, all steps are well explained here. Step by step you go through and try to solve up to this part. Okay, up to this last portion from equation 3 it is written. There are two equations
Sir,
finally. So
sir,
please
some
go.
students are
Yes, yes.
asking to be admitted in the
Hello.
meeting. Sir, some students are asking to be admitted in the meeting.
Just wait. Okay.
Okay, sir.
I think the meeting room is not locked. Just wait. Okay.
So it can be showing post to admit.
Tashi, are they able to join now? Please ask them.
He's not replying. I'll when he replies, I'll go.
Okay, student, please don't leave the meeting. Okay, I need to mark your attendance. And if you have any doubt, you can also ask. Okay. If anyone have any doubt, you please ask. Am I audible to you? Please anyone respond.
Yes, sir, you are audible.
Yes, sir, you're audible. I think we can
Okay, okay. Those who are, please ask your friends to join. If there is someone is left till now, please ask them to join, or they will miss their attendance.
Okay, sir.
And one more thing, all of you, please go through the notes. Okay, whichever I give to you in your classroom also, and here also I have explained. All of you, please go through that. Okay, I think it's
Okay, sir.
not very easy to understand all these things by doing this class. So if you have any doubt, please come up with that in the next class. Okay, and also you can ask now if you have any doubt. You can also ask now. Please go please go through the notes quickly and ask me if you have any doubt. Anyone have any doubt?
Sir, Masanta is still not able to join.
I'm not able to hear you. Please repeat.
Sir, Basanta is saying he's still not able to join.
Vashanta,
Yes, sir, Basanta.
I think talk now. Just wait.
Oh, mm, Sir, Basanta joined.
Please join now.
Yes, sir, she was able to join.
Okay, what is his enrollment ID?
077.
Okay, the student, I think all of you please go through that notes. Yeah, I think you don't have any doubt. Okay, so please come up If your doubt, if you have any, the next class today can leave. Okay, thank you so much.
Okay, sir. Thank you.
One left to give the attendance, please. Michael, have joined now.
I've been here, sir. I've been here, sir.
Okay. Student, I'm going to leave this meeting. Okay, is there anyone left to give you attendance? Michael, are you here?
Sir, 076, sir.